Let's talk about AI. For what feels like forever, the big story in AI has been this mad dash to build bigger and bigger models. But what if that's not the future? What if the next huge leap in efficiency has nothing to do with the size of the AI and everything to do with the data we feed it? We're going to dive into this really fascinating shift in thinking.
The thinking in the AI world has been pretty simple for a long time. If you want a smarter AI, you just make it bigger. You pile on more parameters, you add more layers, you just scale it up. And honestly, this approach gave us some incredible things, right? From these giant language models to AI that can generate unbelievable images. It was, without a doubt, the way forward.
But here's the thing, that path is getting really, really steep. Just throwing more and more computing power at the problem is starting to feel like trying to run through a brick wall. It's not just getting expensive, it's getting ridiculously inefficient. We're bumping up against the actual physical limits of our hardware. The old strategy is just starting to buckle under its own enormous weight. So, here's the game plan for breaking this all down. First, we're going to look at AI's crazy appetite for scale. Then, we'll zero in on this new bottleneck that's causing all the trouble, the data itself. After that, we'll explore the huge shift in thinking this is causing, and then we'll get into the new solution, compressing the data. And finally, we'll look at what this all means for the future of AI.
So, like we said, the story of AI has basically been a race to scale. The number of parameters in these models has just exploded, growing exponentially. But here's the catch researchers are now pointing to. Our hardware, our actual chips and servers, just can't grow that fast. We're getting to a point where our ambitions are outrunning our ability to build the machines to power them.
And this is where it gets really interesting. The main headache for AI developers isn't just about how big the model is anymore. Nope. The real problem, the thing that's slowing everything down, has shifted. It's now the absolutely massive amount of data that the model has to chew on at any single moment.
So, why is more data such a huge problem? Well, it boils down to this concept with a fancy name, the quadratic cost of self-attention. But forget the name, think about it like this. You walk into a party. If there are, say, 10 people, you can say hi to everyone, no big deal. But if there are 100 people, the number of conversations and connections you have to keep track of doesn't just multiply by 10, it absolutely explodes. It's the same for an AI. The longer the text or the video it's looking at, the amount of work it has to do just skyrockets.
And we are feeding our AIs a total fire hose of this stuff. I mean, think about what we're asking them to do. We don't just want them to read a sentence. We want them to understand a whole book. Not just look at a tiny picture, but analyze ultra-high-resolution images and hours of video. Every single one of these things is a massive data sequence that sets off that crazy expensive, exponential workload we just talked about. Okay, so the old method is hitting a wall, and this new data problem is cropping up. Clearly, the field needs a new playbook, and this is where we're seeing a really fundamental shift happen, moving the whole focus of AI efficiency away from where it's been for years. This really boils down to two different ways of thinking. On one hand, you've got the old way, model-centric compression. The idea here is to try and shrink the AI model itself. It's kind of like trying to build a smaller, more fuel-efficient car engine. But the new idea is totally different, data-centric compression. With this approach, you don't even touch the engine. Instead, you change the fuel. You make the data you put into the model way lighter and more energy dense. And hey, don't just take my word for it. This is the core argument of the research paper we're digging into today. The authors put it right out there, saying that the entire focus of AI research is pivoting away from the model and toward the data. And that is a huge deal. So if the answer is to compress the data, what does that actually look like? How does it work? Let's get into the nitty-gritty of this new data-first approach. The big question then is pretty simple. What exactly is data-centric compression? At its heart, it's all about making the AI's job easier from the get-go. Instead of just dumping a gigantic raw file on the model, you get smart and you shrink the input first. So, for instance, imagine you need an AI to understand a 100-page report. The old way is to make it read every single word. The new, data-centric way might be to first create a super dense one-page summary of all the key points, and then feed that to the model. You're giving it the same essential information, but with way less data. You're basically pre-digesting the world for the AI. So what does all of this mean for the future?
Well, recognizing this shift from focusing on the model to focusing on the data isn't just some academic thought exercise. It completely reframes the entire field and points us toward a whole new set of challenges and, honestly, some incredible opportunities.
The researchers lay out a pretty clear path forward. First, they say the whole AI community needs to agree on a way to talk about and compare all these different data squeezing methods. Second, they need to go back and sort through all the stuff that's already been tried. And third, and this is the big one, this new focus should kick off a whole new wave of creativity all aimed at solving this problem of ridiculously long data inputs.
So, if there's one thing to take away from all this, it's this. The future of making AI better and faster isn't just about a race for bigger and bigger models. The next big thing, the real revolution, is almost certainly going to come from how we get our data ready before it ever touches the AI. It's about working smarter, not just bigger. And that leaves us with one last really cool question to chew on. If we actually pull this off, if we make AI way, way more efficient, what kind of problems that seem totally impossible today will we suddenly be able to solve? What new giant challenges will we point these super efficient machines at? Something to think about, right? Thanks for tuning in.